For most of us, the moon is a ball of rock reflecting the light of the sun, just like every other object we see every day. For flat earthers, though, it seems to be a conundrum. In the eternal quest to deny reality and discard knowledge, flat earthers seem to have shed the ability to comprehend simple everyday observations. One of the more prolific examples of this is the sudden inability to fathom how light from the sun interacts with the moon. This particular problem tends to surface in the form of claims that the moon shouldn't be visible in daytime, and many videos can be found on YouTube declaring triumphantly that the phenomenon is somehow proof of flat Earth. Even more bizarrely, some people actually question how the moon can be visible at night. Apparently this stems from the notion that if sunlight is reflecting off the moon, then when the sun sets, it can no longer be casting light upon the surface of the moon. So, it seems as though the self-proclaimed critical thinkers who claim to know more about physics and the heliocentric model than the entirety of the rest of humanity throughout all time, including the many astronomers and physicists who dedicated their lives to observing and measuring the solar system, can't understand the simple concept of light being cast by a single source upon two objects in three-dimensional space. This does seem to be a highly selective handicap, though, given that we all experience far more complex examples in our everyday lives involving multiple objects, and no one has any problem processing that information. For example, in this image, a person standing with their back to the shadow side of a tree would expect to see the lit side of any remaining trees spread out in front of them and wouldn't give it a second thought. Another common example here, which most can experience, is standing on the colder and darker side of the street in the shadow of a tall building while observing the opposite side fully lit by the sun. In the final image here, the photographer would be lit up by the sun while observing the shadow side of the objects in the scene, while if they were to change their position by moving into the street, turning and looking back, that would place the camera in shadow and obviously would result in a photograph displaying a mix of cars and people brightly lit by the sun. So, in spite of these and many other observations occurring throughout the day, and throughout in your entire lives, basically involving vast numbers of three-dimensional objects in a large three-dimensional space, for some reason, when we narrow down the number of objects involved and move up into the sky, flat earthers suddenly become extremely confused by the common behaviour of light and shadow. So to address this, I just set up a very simple practical demonstration using a single light source, two spheres to represent the moon and the earth, and just try and give a visual aid to demonstrate how the light from the sun would actually light up these two objects in space and why you would be able to see the moon, whether it be in daylight or nighttime, when looking from the earth. So what we have here obviously is the earth lit up by the light source, which is behind the camera, and then the moon, obviously the same because they're both sitting in front of the light. I've just lift the camera up here to show obviously the other half is in shadow. There's another angle there just to show how it looks. So obviously you can see, one half is lit up, there's a terminator line. So this is your front facing side. I've marked a point in this, it's supposed to be where the UK is, just as a point of reference, obviously facing on the day side toward the sun, and we're just spinning the globe to simulate obviously the rotation of the earth. At this point it's just hitting the terminator line and going into night time as it would be, and then as it moves around a little bit further, that's moving it a couple of hours into night time. So obviously the sun hasn't moved, the earth has just spun away from the sun. The moon is still visible because of its relative position to the earth. It's still lit by the sun and it can be seen from that point on the globe. And we'll just change the camera angle here just to show. So a person standing at that point that we marked can see across to the moon, and obviously our field of view would be much wider, it wouldn't be a direct line like that, so anything within our field of view is visible, and you can just see that from the rear here. So again, coming from the shadow side, you can see the lit side of the moon. Now normally, the moon obviously wouldn't be right next to the Earth, and it also wouldn't be on the same plane. It doesn't sit on the same ecliptic plane. It's slightly off by a few degrees, so it may be higher. So that was just to show that. And then I've just taken some random pictures moving the ball around that represents the moon to show a few different positions that the moon could be in with relation to the Earth, and you can see, the crescent that you might see depending on the position throughout the year. So obviously none of this is to scale, and it isn't meant to represent the proper moon phases. It's not a direct model of all of that. It's just a general example of how changing the position of the moon around the Earth might change where on the Earth you would see it from and how you would view it, depending on the light and shadow from the sun. For example, here you've got an eclipse as the moon obviously sits behind the Earth, and it's just a case of demonstrating as you move it around in a circle around the Earth that obviously where an observer is based on the Earth will determine whether they see the moon lit up, partially lit, whether they'll see it during the day and be able to see the sun as well, or whether they will see it from the night side. It's just very, very simple stuff. It's all to do with the relative position of these two objects as one moves around the other, while the third object, the sun, obviously casts light in really one direction all the time. And as I said earlier on, this is a simple relationship and very easy to understand, and we deal with much more complex examples every day in everyday life, but for some reason this guy seems to confuse a lot of people, and I hope that just this simple enough demo will show how simple it actually is. Thanks.